Good afternoon everyone. Thank you for joining our webinar Enterprise Big Data versus Smart Data, Differences, Approach and Use Cases. Today our speaker will be Maruti Kampli, who is working as a practice manager for integration. Maruti will take you further of the webinar. Maruti, it's all yours.
Thank you. Good afternoon everyone. This is Maruti Kampli. Thanks for joining our webinar. So today we'll be actually talking about enterprise big data versus smart data, and we'll be explaining to you what are the big data differences, approach, and use cases. I'm slide number 2, agenda slide. So we'll be talking about a miracle story. And then a roadmap for big data and smart data, and we'll be actually talking a bit about the big data, what it entails, what are the 3 V's, which are the most important characteristics of a big data platform, and we'll be talking a little bit about challenges in handling big data and everything to do with smart data architecture, smart data use cases, miracle story. So who we are as a company. So Miracle Software Systems is a global company, and it's an integration software company with almost like 20 plus years in business, based out of Detroit, corporate headquarters being in Detroit, Michigan. And we have offices worldwide, and we have about like 12 global locations, 15 plus technology partnerships, and 2,000 plus employees globally, and more than 100 Fortune 1000 customers. And the way we are doing the business is all about ensuring that we meet the customer, we meet and exceed the customer expectation, and also we want to propagate or make the customer aware of all the ways in which they can go with an affordable innovation as far as the enterprise is concerned, and also we focus on quality and efficiency for services. Talking about Miracle's core industry expertise. So we have a large pool of certified resources. So we are a premium business partners with IBM. We are partners with SAP. We are even a gold partner with Microsoft. And we have a lot of certified resources. And the key differentiating factors between our company and our competition is the emphasis on using reusable frameworks. So be it, we are technology agnostic, so whatever the technology might be, whatever the services that we are offering to our customers across different industry vertical domains, we actually emphasize a lot on using reusable frameworks and accelerators, and the cost of actually putting an enterprise architecture in place will tremendously come down because of our reusable frameworks. And that actually the ROI, we have shown it to our customers in terms of the validation in terms of ROI that our reusable frameworks brings to the table. So that's the number one thing that we actually drive to. And all the other things are also there, like global delivery, and then we do a lot of other core area things as far as the technology implementations are concerned. Industry verticals. So these are the domains that we cater to: manufacturing and automotive, energy and utilities, healthcare and pharmaceuticals, retail, logistics, supply chain, banking and insurance. And there are also many other domains which are not there because we just couldn't fit all those things in this particular slide that we actually cater to on a day-to-day basis. Initially, I spoke about our strategic partnership of being premium business partners with IBM and Oracle and SAP and Microsoft. We just wanted to show you what we have got in terms of our partnerships. So we are a premium business partner with IBM, and also with Oracle, with Apache, with Atlassian and then Amazon Web Services. So there are a host of different companies, major companies that we have a very close relationship with, and it entails that we leverage their technology when we are actually implementing them at various different client locations. Big data and smart data roadmap. And at slide number 8, what's a big data? So as everybody knows what a big data is, day in and day out we are hearing about all these enterprises actually working through large data sets and then trying to analyze how the data would look like, and also trying to come up with a forecasting model. So the ultimate goal of any enterprise is not how it actually structures the big data, but what comes out of it, and then how it can be applied to actually enable the enterprise to show value addition in terms of operation efficiency, and also putting the right things in place as far as the operation efficiency is concerned. So that's the whole idea of having a big data in an enterprise. And we just wanted to show you some examples. We actually, so for example, Walmart, everybody knows Walmart, so it handles more than like 1 million customer transactions every hour. So that entails it has to deal with like a huge amount of data. And again, everybody knows Facebook, and also the fact that it handles like 40 billion photos from its user base. So basically, we're talking about a non-structured data versus a structured data and how to deal with that. So this is what forecasting would look like purely from a big data market forecast. What happened in the past couple of years, and how it looks like in the next couple of years, and how it has progressed, and how the transition has happened. So we just wanted to show you an insight of how the market is reacting to the big data. So the 3 characteristics of big data. So what they call it as 3 V's. So you have your volume, which is nothing but your data quantity. You have your velocity, which is nothing but your data speed at which your data is flowing, be it real time, be it batch mode, and then a variety, which is a data types, basically what kind of data you're dealing with. But again, there is a 4th V, which I will be talking about a little while later, and that's where the whole big data versus smart data comes into the picture. So initially, when enterprises started adapting or managing their big data, and then they actually focused purely in terms of these 3 V's. But later on, as things progressed, they realized that it is not just about reacting to data coming in, but actually there needs to be a process put in place before that reaction to the big data happens, so that you filter out what is needed versus what is not needed. That's the whole concept of having a smart data module in the big data environment. So the way in which you react to the data coming in to your enterprise, and what are the things that needs to happen so that you eliminate some of the things at the source, so that you are dealing with the correct amount of data, is what the smart data is all about. And that we are going to talk a little bit about in the subsequent slides. And coming to the character of a big data, so first we talked about the first V is the volume. So you could say it as data at rest. So this is just an example. A typical PC that we work with might have had like 10 gigabytes of storage in 2000, but there are some enterprises today which have like 500 terabytes or 250 terabytes of data they deal with on a day-to-day basis. So that's when you're talking about your data volumes and how you ingest that data. So the smartphones and and the data points which they create and consume. So those are kind of like they create like billions of views of new data. So again, the whole concept of the Internet of Things, how the data interaction happens, and what are the different touch points of data. That is the character of how you deal with the big volume, and that's what you mean by the big data volume. And the second V that I spoke about earlier was velocity. So it means the data in motion. So a streaming data. So you normally, typically, you would have like a millisecond to second to response for any enterprise, a large enterprise, which you're dealing with, where you're dealing with like data in motion. You would have almost a millisecond to respond and adapt and get some analytics if you want to actually come up with a good use case around your situational analytics. And that's when you would actually have to take into account the amount of time you need to respond to the data in motion. And again, we just wanted to present you with examples of how the large enterprises they talk about when you talk about data velocity. You talk about like ClickStreams and Ad Impressions. So basically, any major website that you go to, they have this enabled, which will actually capture the user experience or the user behavior with like thousands and millions of events per second. And the best example that we have right now is with the stock trading. So any algorithms, the real-time algorithms that they have in place right now, it is not only that those algorithms have to run, which will actually change the market conditions within microseconds, but also those algorithms are kind of like adaptable algorithms, so they need to be adapt to certain situations. So those are pretty good examples of dealing with data in flight. And again, machine to machine, I spoke about. It's again a big area that we as a company are heavily invested in. So anything and everything to do with IoT. So we are seeing a lot of opportunities in the market space where this machine-to-machine transaction is increasing day by day in terms of the data that they exchange and how you process that data between large number of devices. It need not be just the smartphones or the smart devices, but any device to any device is where we are seeing a lot of traction in terms of how do you deal with that data. And also when we talk about infrastructure and sensors, so we are working with large customers where each and every, for example, they sell something from as simplest of a simple lawnmower to the most expensive car that you have. Nowadays, all the everything is driving towards this having a smart device in place. So they will have innumerable sensors in them which generate like massive amount of data real time. They not only let you know how that particular device is working to actually know their working status, but also to diagnose any issues or anything that you might have with that particular device. So that's where we are seeing a lot of traction in terms of your internet, anything and everything to do with Internet of Things, and how that ties to the big data is what we wanted to actually lay out here. And also the best example would be the online gaming systems. So again, online gaming systems, there's about millions of concurrent users, each producing multiple inputs per second. So again, moving on to the next slide, slide number 12. So the big data variety. So again, when you're talking about variety, data, it basically means data in many forms. It could be a structured data, it could be an unstructured data, it could be a text, it could be a multimedia. So the biggest problem that our customers are facing right now, or any of the enterprises are facing right now, is how do you actually differentiate between a structured data and unstructured data, and also how do you take into account the unstructured data, and how do you put analytics on top of the unstructured data. So it could be a geospatial data, it could be an audio video data, or any unstructured data. So it could be as simple as a log file to anything and everything to do with social media. So traditional database systems that we have in the market space, or which the enterprise uses, they are actually designed in such a way that they address smaller volumes of structured data. So with big data, the whole concept of having your data warehouse in place, how do you actually architect data warehouse, how do you actually take into account the data coming in, is what matters the most as far as laying out this architecture is concerned. And in our experience, what we have seen is that is the most important fundamental thing. So when we talk about any enterprises starting in their journey towards a big data path, be it any technology, as the first and primary thing that we have done is to make sure that the architecture is laid out properly and storing big data. So analyzing your data characteristics, selecting data sources for analysis, eliminating redundant data, and establishing the role of NoSQL. So nowadays, most of our customers or any large enterprises, they are going towards a model of doing away with an on-prem model. So be it any of the infrastructure hardware servers or be it a database, they're talking about like everything and anything to do with cloud, and also the emphasis of having a NoSQL database. So basically, how do you manage a big data store? So you have your Hadoop distributed file system, which they call it as HDFS, and how do you implement that in your enterprise using all these data models? You have your key value, you have your graph, document, column family, HBase, and all these things. So this is basically that becomes your first step in putting out this architecture of how do you store your big data and how does your big data store would look like. And moving on to the next slide, selecting big data stores. So based on the data characteristics, now implementing polyglot data store solutions. So nowadays, when you're talking about a very large enterprise, for example, in the range of Walmarts of the world, it is not just one data that you're dealing with, but you're dealing with like multiple data sources, and that's the whole concept of having this polyglot data store solutions. When you're dealing with a polyglot data store solutions, it becomes even more complex in terms of how you design your HDFS and how do you actually put your algorithms in place to actually track and then establish patterns for that data. And then if you want to do any kind of a data analytics on top of that, how you do that. So that's the most important thing, is actually having all this architecture laid out before you start the big data journey. Moving on to the next slide, slide number 15, processing big data, integrating disparate data sources. We talked a little bit about that. Now this is if you want to implement Hadoop and how you're going to implement Hadoop. So you have your Hadoop HDFS, and then you have your MapReduce. If you want to, the first thing would be to map the data to the programming framework. So how do you extract the data from sources and transforming data for processing? And then the whole concept of Hadoop MapReduce, where you divide the data into like multiple blocks and then apply MapReduce per block, and how that Hadoop MapReduce job would look like. So basically, it all depends on how complex the enterprise data enterprise is and how you actually tackle that. So that's the whole idea of having this processing the big data, as far as the architecture of processing the big data is concerned. The structure of big data. Now, again, in our experience and also in dealing with large enterprises, what we have seen is it could be the data that we're dealing with, could be a structured data, could be a semi-structured data, or it could be an unstructured data. And we just wanted to give an example of what it might look like. And in our work which we are doing for our financial domain customers, most of it would be real-time data. So anything and everything to do with the monetary data, 99% of the times it's a real-time event. And anything that we are actually, we are also working with our retail customers in the big data space, and that could be in terms of your demand forecasting. We are working with a manufacturing customer, so demand forecasting is a very important primary component of that. And the way we work is to actually analyze the data, and that could be a form of a batch data. And each and every category has to be handled separately. So it could be structured, semi-structured, or unstructured, and how we categorize that. So this is predominantly how your structure of a big data would look like. Again, we just want to show you exactly how your data transformation and also the amount of data, the systems of interaction, and the data that actually emits out of those systems, and what you could expect if you're new to a big data space is this. So it's just an example. We just wanted to present it with a use case. Like, for example, if your enterprise is predominantly dealing with an ERP, you could be looking at something like megabytes of data. If you have your ERP and CRM and web, then it could be like a terabytes or a petabytes of data. So that will give you at least a kind of like an overview of what is the amount of data that you're dealing with and how you deal with that. So big data is nothing but transaction plus interaction plus observation. That is nothing but the whole concept of a big data. Now, initially when I spoke about, I'm going on to the next slide, slide number 18. So when I spoke about the three main characteristics of big data, it is like volume, it is velocity, it's variety, and the fourth one, which would actually make it smart, is the veracity. So the largest enterprises, especially the financial domain customers, what they are doing is predictive analysis is the primary important factor driving any big data enterprise. And before even they come to volume or velocity or variety, they are taking into account this fourth V, which is veracity, which is nothing but data in doubt. So basically, you might be dealing with a lot of structured data, a lot of unstructured data. Example, there might be some component of the data which is not usable in terms of when you're dealing with a lot of metadata information, which may or may not be useful as far as applying all the business rules are concerned. So the goal of an enterprise would be to actually put an algorithm in place where you can eliminate all that noise upfront. Thereby, you're dealing with a limited amount of data, and the entire amount of data is actually valid for you to manage and then come up with a process or manage the whole big data process. So that's where the entire smart data comes into picture. So there is no such kind of like architecture which will differentiate smart data versus big data. But the way the enterprises are looking at it is they want to introduce this additional component wherein there is some kind of a check in the front which will eliminate all that redundant data and then get the data which is absolutely required by your enterprise to run your big data enterprise. So that's the whole concept of having the smart data in place. And how do you harness big data is basically, if you want to categorize it between different categories, so it could be something like an OLTP, which is online transaction processing, and then OLAP for your analytical processing, and then real-time analytical processing. So that's where we have seen that these are the three ways in which you can harness the big data. Who's generating big data? So basically, it could be anything with social media networks or scientific instruments. So in our case, these are the things that we have seen or we have come across in talking to our customers on a day-to-day basis. Like these are, I would say, the different categories in which we deal with big data day in and day out with our customers. And we just wanted to show you an example here. Again, this is pretty much old. In the olden days, it was kind of like a few companies were generating the data, and all of us were just consuming the data. Now, no matter how small or how big, everything is generating all the companies, all the enterprises, or all the systems are generating data, and all the systems are consuming the data too. So it becomes even more complex in coming up with a very efficient big data processing architecture in which this happens very seamlessly. And as I said before, what's driving big data, at least in our experience, what we have seen talking to our customers is the predictive analysis and data mining. That's when you put all your optimizations and predictive, especially I'm talking about all these manufacturing and retail customers that we are working with on a day-to-day basis. They have very large data sets, and it will be more like a real-time data, and they want to do a lot of predictive analysis, especially in terms of retail landscape, predicting how the customer would view the customer behavior and those kind of things is what driving the big data, and also the BI part of it. So we cannot discount the BI part, the business intelligence part, where you have your ad hoc querying and reporting, data mining techniques and all that. So the value of big data analytics, again, it's more in terms of real-time in nature than traditional data warehousing applications. And so basically, traditional data warehousing architecture, if you look at it, is still kind of like gearing more towards the structured data. But if you're dealing with large amounts of unstructured data, then you would be talking something like a big data. And challenges in terms of handling the big data. So again, the bottleneck is the primary thing that we are seeing is the technology. So be it like architecture, defining the architecture, defining the algorithms for effective situational kind of like predictive analysis, situational analytics or things like that. That's where we are seeing a huge gap when we talk to our customers in terms of how to adapt to this particular technology and how to actually have that architecture in place because each and every customer is different, each and every enterprise is different. So every enterprise will have its own challenge, and what we are doing is we are analyzing each and every use case as a separate use case, and then trying to see which is the best fit in terms of that particular enterprise as far as handling the big data is concerned. And these are, I'm in the next slide, slide number 25. I just wanted to explain what are the moving parts as far as the big data is concerned. So you have your fast data, you have your analytics, you have your insights. As far as your analytics is concerned, you have your SAS, you have your all the other things that are there available out there. As far as your data transaction is concerned, you have your, we talked about Hadoop a little bit, we talked about MapReduce. There is Vertica, there is KDB. There's just a whole lot of things that are in place. Also, traditional enterprises are still relying on any of the ETL and the ECL as far as analyzing the data is concerned. 27. So basically, again, the pain point is traditional enterprises are still struggling to meet these needs. So day in and day out, they have requests to get more data in more places. So more number of systems are asking for that data, and it's like a rapidly changing environment. And every day there's a new systems which request for this data, and this enterprise needs to be adapted to that kind of environment, and that's the biggest challenge that we are seeing as far as the enterprise data trends are concerned. And when I spoke about the smart data, I'm at slide number 28, and I spoke about smart data at the beginning. It's like you have your smart enterprise data management, you have your smart data layer, or you have your sources of generating the data, and then you have your integration layer in between. It could be a SOA integration, it could be an ETL integration, it could be an MDM. The way in which the enterprises are setting this up is to kind of like eliminate the unwanted data from the data sets that have to be analyzed. And that's the whole point of introducing this middleware layer in between, and then take the data which is ready to be analyzed and then have that in the storage layer. And then depending on how and who is consuming that, then it could be sent to the appropriate consumption layer. So that's the whole 9 yards as far as setting up the smart data enterprise data management is concerned. This is just an example of the architecture that we have set up with one of the manufacturing and retail customers as far as setting up this whole smart enterprise data management is concerned. and how do you set up dealing with big data. And as far as we just want, this is again the same example, we just wanted to expand. So you have your middleware in between, you have all your applications, front-end applications, and you have your enterprise data fabric at the back end. And basically, how do you deal with the unstructured data? So basically, in this case, we are actually streamlining that and then taking into account if we can have one particular module just for the unstructured data, and then have all the structured data into different data warehouse entities, and then have a workflow set up, and then business rule set up on top of that data, and then have that final output product to be exposed to the front-end applications. So that's the whole architecture that we have set up. And this would be a prime example as far as your smart data is concerned. So basically, we are taking the big data and we are eliminating some of the unwanted data at the beginning, and then dealing with that or applying Hadoop on top of that, and then having that data exposed to various front-end applications. That's the whole concept of having the big data versus smart data is concerned. So the challenges that we have seen so far is again MDM and metadata management again becomes a very critical part of it, and also how this SOA or service-oriented architecture fits into the whole scheme of things. So when you have this enterprise where you have your growing data volumes and data types, how do you actually come up with that? So that's again a typical challenge that we have seen at our customers. And also this demand from the business users. So every day there's a new set of demands of what kind of data has to be exposed to what different system or user. And that's a constant challenge that we deal with on a day-to-day basis of how to streamline that whole process. And typical data migration environment, you have your source systems and you have your ETL. So this is again other customers of ours where you have your ETL primarily taking care of the entire data management, dealing with large data sets, and then exposing the data to the target systems. And as far as data migration is concerned, these are typical challenges that we have seen. So complex coding of transformations, especially when you're dealing with like unstructured data, how do you transform the data and those kind of things, and loss of data provenance and high cost of change. So basically onboarding new customers, it usually takes a month. So typically the goal is to reduce that time by using these concepts to weeks or days for that matter. And again, this is just another example where you have your function applications which consume the big data. You have your data server where you're actually transforming the data, and then you have your ETL engine on the backend side. So this is a typical example or use case where we have implemented big data. So smart data migration benefits, again, traditional ETL is complex transformations, high cost. Smart data is abstractions, transform abstractions, smart business model, and low cost to implement and change because we are dealing already with a structured data. So we can eliminate an extra layer where you need to analyze the data again as far as putting up some new processes concerned. So again, I talked about a little bit about a large financial company reducing the client onboarding from like months to weeks and days by using smart data enterprise. So the benefits we just wanted to lay out. We talked about reference data management. We talked about MDM. We talked about metadata management, service-oriented architecture, data migration. So how do we get a shared view of enterprise data, and then how it can be actually presented to the business in a consumable form? These are some of the benefits that we derive out of following the enterprise data management, smart enterprise data management architecture. And then we obviously, the good part is promoting quality and reuse of, and eliminating the redundancy as far as data or process is concerned is the whole premise of it. So for financial customers, we just want to present smart data management and business solutions, so smart SOAR governance. These are some of the use cases which directly applies. So it could be pretty much smart ETLs, research and intelligence. When you're dealing with, it all depends on what kind of data that you are dealing with, be it like real time or batch mode, and how it fits into that particular business needs. That's pretty much it that I had. I think I overextended by like 8 minutes, but we are here and we are more happy to answer any questions that you might have. And Lakshmi, can you take it up?
Yes, thank you, Marty. If you do have any questions, please do raise your hand to ask questions, or you can push your questions in the chat box too. Since we don't have any questions, taking you further, here are the upcoming webinars that are going to held in this month. We have Building IoT Mobile Apps Using Xamarin and Azure App Services that is going to be held on July 28th. And we have one more webinar, Exploring MuleSoft's Anypoint Platform for Hybrid Connectivity. This will be held on August 4th. And you can check out more webinars at www.miraclesoft.com/webinar. Coming to digital transformation and Miracle, we do health check workshops, digital transformation workshops, and we are doing labs and center of excellence teams can help you with a pilot or to build a roadmap for your next generation digital transformation initiatives. Thank you once again. To learn more, visit www.miraclesoft.com, and you can tweet us at @team_MSS, and you can watch our videos at youtube.com/miracle45625, and you can like our Facebook page at facebook.com/miracle45625. Thank you once again and have a great day.